All right, now we're going to talk about, in section 7.4, we're going to talk about properties of log functions, or things that you can do to logs to either simplify your problems or make them more easy to use to solve equations. And that's the goal. The goal is to use these to solve equations, which is what we're going to do in section 7.5. All right, first of all is the product property. What the product property says is if you have a log to some base b, and you have two things times together, which I'm going to color code in here. Let's call them m times n. You can write these as two separate logs. Log base b, the base stays the same, of m, whatever that is, plus log base b of n. That's the product property. You can split them apart. You can split these two things apart that are times and add, and you use two logs to do so if you're timesing two things together. The quotient property works very similarly. The log of base b, and if you've got two things that are divided, m divided by n, that's the same as writing it as two logs, log base b of m, whatever the top number is, this guy right there, minus the log base b of what's in the denominator, n. That guy right there. That's the quotient property. And finally, the power property says if you have the log base b of some number m, or some letter m, to the n power, that's the same as moving the power out front and timesing by the log base b of m. And that's your power property. Now, if you need to, please pause the video, and then I'm going to do some examples for you. All right. Expand each logarithm. In other words, write as multiple, multiple logs. Multiple, more than one. All right, well, I'm going to look at my first problem. It says log of 10x divided by y. Now, the first thing that we need to make sure we know is if there is no base, it is always 10. So you notice there's no base here. I got to write this in. There's a 10 there. If there is no base, it is always base 10. Make that note to yourself right now. All right. I got to write this as multiple logs. Well, what do I notice? First of all, I notice there's a times sign in there. So that means I'm going to have to use the product property. And I also see there's a divide line. That means I'm going to have to use the quotient property. So, if I was to break this up, I would write this as the log base 10 of the numerator, 10x, minus, because there's divide, so I'm going to change it to minus log base 10 of y. Okay, well now, you're going to ask, well, there's times there, Mr. Heuner. Yes, there is. Which means we got to split the first log into two pieces. The log base 10 of 10 plus the log base 10 of x. That's this first piece right there. And then minus log base 10 of y. Now there's one other rule that I want you to follow. If you have a log that has no variables in it. If a log has no variables, evaluate it if it works out evenly. Well, log base 10 of 10. We did this on a prior video. That means 10 to what power is 10? That's what you're asking yourself. Well, that case, obviously x is 1. So in this red circle, that becomes the number 1. So my final answer becomes 1 plus log base 10 of x minus log base 10 of y. And that is the expansion of our original problem right there. All right, good. Let's do number 2. Log base 9 of x to the 4th divided by 729. Well, take 2 seconds and analyze it. First of all, we have a power, and second of all, we have divide. So we need to use the power property and the divide property, the quotient. So I'm going to write this as log base 9 of x to the 4th. I'm going to break the divide up first, minus log base 9 of 729. I'm going to erase this bottom problem, give us a little bit more room. Now, we have a power. First of all, the power goes out front, as you saw in the power property in the previous slide. So I can write this as 4 log base 9 of x. That'll take care of this piece. We're done with that piece. Minus log 9 of 729. Can we evaluate this? There's no variable in it. So 9 to what power is 729? Well, I believe that you'd come up with an answer of 9 times 9 is 81 times another 9. I believe the answer is 3. So this whole piece right here becomes the number 3. And that's it. Problem 3 that I just erased. Log base 9 of 9x to the 5th power. Well, there's a times sign and there's a power. So I'm going to break this up into the log base 9 of 9 plus the log of x to the 5th. And just like the previous one, log base 9 of 9, that's 1, plus, and then the power goes out front, which would be 5 log of x. And you're done. That's how you expand, everybody. Now, let's go the other way. Write as a single log. All right, well, first of all, when you write as a single log, you first got to see, are there any numbers out front? And if so, those become the powers. You have to put that back. So this is really log base 2 of x to the 6th. And there's a 5 there, which is really log base 2 of y to the 5th. All right, so now we got to write it as a single log. It's plus. This means it's the product property, which means the things that I'm underlining you have to times together, the stuff inside the log. So finally, this becomes log base 2, parenthesis, x to the 6th, y to the 5th, and you're done. You have now written it as a single log. Number 2. Again, I'm going to notice that there are stuff on the outside. Those become the powers. So this would become log base 3 of x squared plus log base 3 of 7 squared. It's add, so again I'm going to multiply the stuff on the inside. Log base 3, and what's on the inside is these two things. But one thing I notice is they have the same power. So since they have the same power, I can write it as 7x and then put the power on the outside since the 2 applies to both the 7 and the x. And I'm done. Last one. Log base 4 of 2 plus log base 4 of 16 minus log base 4 of 2. Well, let's add to begin with. That means I got to take the two pieces and times them together. That means I would have log base 4, and 2 times 16 would be 32 on the top. And then it's a minus, which means divide by that 2 on the bottom. Well, I've written it as a single log, but I can simplify it because there's no variables. So log base 4 of 32 divided by 2 becomes log of base 16. And you can evaluate that because what it's asking you is 4 to what power is 16? And that answer is 2, which would be your final answer to that problem. And that's how you use your properties, people, of logarithms.